This is from Space-Time Insight, real interesting company that's doing some things around situational intelligence that we've explored a little bit, and it's very interesting. And from Space-Time here today, we have Rob Masudi, who's the Senior Vice President of Business Development and Strategic Partnerships. So I will hand it off to Rob, and we'll get started. Thank you.
Good morning. Thank you. I'm Rob Masudi, and I'm going to talk to you folks about probably some of the hottest topics in the industry today, which is geospatial visualization and big data. Seems to be the topic. And I think all the presenters before me spent quite a bit of time. My colleagues have done a great job of articulating what are some of the challenges associated with the big data and the value and importance of visual analytics, guided analytics, situational awareness. And now we're going to take it one notch further. We're going to talk about situational intelligence, which is really an emergence and evolution of situational awareness. So over the next 20 or so minutes, I'm going to talk to you about how we define it, and I don't think you'll find it any different than the way some of our colleagues defined it, and how, our perspective and view of what do you do with it and how you address it. So again, I think that's where we're going to find some differences in the views and opinions and the way that we look at how you approach the problem and solve the problem. That's the innovation that makes us all unique in this space. So let me just get this. There we go. So a little bit about our company. We are now delivering applications and solutions in some of the largest utility companies in the world, not just the ISOs, but also IOUs, in partnership with some of the leaders in the industry in both the technology and the system integration side of the business. And the solutions that we're delivered today in the mission-critical business operations environment of some of our customers include asset intelligence and around asset diagnostics and condition-based asset management. They include smart meter in terms of smart meter diagnostics, as well as some revenue protection use cases. We'll cover one of them today. Renewable intelligence and renewable integration, highly unpredictable source of energy generation and very important to all of us. And of course, in and around the grid intelligence and wide area situational awareness of the state of the grid and operation of the grid. And some of this is used in optimizing maintenance strategies, optimizing service strategies, optimizing the system planning, and ultimately, over long term, smoothing out the asset investment curves. So that's what we're going to talk about in the next 20 or so minutes with you. And by the way, if you appear in one of our videos, you're likely to win an award. So that was Jim actually won an award at the Distributech, which happened a couple of weeks ago. So problems. What are the problems? And I think again here you'll find that there is no diversion or a difference in opinion in terms of what is the problem we're all trying to solve with the next generation of analytics. Those problems are pretty much related to the vast amount of assets that we have and the geographic disbursement of those assets, the geographic location of those assets. It's all about vast quantities of data, and it's not just, real-time data. It's not just big data. It's complex data. And the fact that we have, in essence, in our industry today, a siloed approach to addressing and using this data, right? And the tools that we have today don't allow us to really bring it all together and look at it in a comprehensive 360 fashion. And then, to add to that complexity, we also have external events. And these external events like fire, earthquakes, storms, change in temperature, the weather, also man-made events like construction, some of the other things, really have an impact ultimately on the demand and the supply side of the equation, which then, in effect, affect our assets, which then affect our ability to deliver services. So it's pretty simple. I think it's pretty straightforward. We all see the same problem in the industry. We're all grappling with the same thing. And as I said earlier, it's how we look at it and how we deal with it and what solutions we bring to bear to help solve these problems for our customers is where the differences are. So we view there are really three components to solving this problem. There are three key requirements. I think my colleagues talked about it a little bit earlier, right? First requirement is the federation of that data. Got to acquire the data. Got to bring it in. And the trick here is to do it without impacting or affecting or requiring a change in the fundamental infrastructure of your data and where your systems are. So being able to overlay on top of these systems, being able to extract the relevant data, federate that data, and really understand that data. The second problem with data is that not all data is the same, right? So we have business intelligence, right? We have business analytic tools, and that's generating a lot of business intelligence. We have ERP systems. We have CIS systems. So not all data is the same. We have operational intelligence, right? The EMSs, the DMSs, the OMSs, et cetera, and bringing in all that SCADA information. And that data is fundamentally different. Then we have sensor data. We have real-time data, machine data. And how you operate on that data is also very different than how you operate on business intelligence. And there's certain bits of knowledge and information we get out of one kind of data that we're not going to get out of the other kind of data. So bringing it all together and being able to combine the operational data and operational intelligence and business intelligence and business data, and we now say one more piece of data that's becoming even more relevant over years is structured or unstructured or social data. It's everything that's happening in the social space, right? The tweets, the webs, et cetera, et cetera. So structured, unstructured, real-time, historical data, all from different environments being brought together and made sense of. And there's attributes around the assets. Well, each asset behaves differently. A transformer is different from a feeder, is different from a transmission line, is different from a meter. And all assets are geographic based. And all events impact assets on a geographical basis. So a lightning strike that happens, say, I'll just pick a location, in an area of Orlando, right, that comes close to a transformer is not going to have the same effect as something that happens in Miami. So all those events are local and geographical. So being able to understand the nature of the asset, the impact of the events, and that data as it's associated with that asset, and the implications that then that has on our risk, liability, reliability, safety, revenue, is really what we're trying to solve here. So, in comes situational intelligence and the era of Renaissance. Kind of pulls us out of the dark ages. Situational intelligence, in essence, is the ability to pull in all of that data and information and introspect that data and information with the geography and the assets and the behavior of the system as a whole. So, ERP data from data warehouses, the environmental data, the grid data, the meter data, the enterprise application data, so on and so forth. And really to be able to analyze that data in real time. I think my colleague just before this presentation said, the biggest outage took 8 seconds to occur and probably days to resolve, right? So being able to see that and understand that, where is the problem occurring, when it's occurring, not only in real time, but also in a predictive fashion and sometimes in a simulated fashion, right? You need to be able to train the folks who are going to be able to predict or understand the problems. Understand when it occurred, and really, what is the root cause? Why did it occur? Why did it happen? And what is the implication of that on what really matters to me? And the customers that are impacted, on the asset that I need to go and replace and fix, and bring the service back up, right? And then how do I address it? Which what we call adaptive response. Because as we know, conditions could change dramatically, and they could change at any given time. So adaptive response then becomes really critical, because as the nature of the problem changes in real time and dynamically, you have to be able to adapt to it. An example to bring it home. So the weather, the temperature goes up 10 to 15 degrees. My lines are overheating. The vegetation is pretty close to my line. Okay. That's cause for concern, right? But then all of a sudden, there's a fire. Okay, now I need to respond differently. and to be able to detect that and deal with it in real time. That's really key. And of course, more and more increasingly, what we're going to see is the emergence of predictive analytics as an integrated part of this guided analytics. And the guided analytics is nothing more than being able to adapt your response through the analytics in real time and then impact the business processes or make changes in the business processes in the back office. And that's really the optimization of the strategies around maintenance, service, system planning, system design, and so on and so forth. Okay, so an asset intelligence example. Understanding which assets are exhibiting signs of stress under load. Understanding the implications of that asset and its potential condition, the maintenance that was performed on that asset, and its potential risk of failure in real time, right? Then being able to look at the history and understand or see the pattern of that asset failing under all of those conditions replicated. And then being able to understand and understand when that failure occurred, where that failure occurred, which then allows you to have a more accurate field service ticket and better ability to address that situation. Now, I also say that all of this insight intelligence also helps you build better rate cases, right? So what we used to assume were 50, 60, 70, 80, 9 years of life cycle for some of the more expensive assets, and those are what our financial models are built of, are not necessarily the case going forward. And we need to then have better use cases. I mean, we have one customer who fundamentally is dealing with that problem today, right? The rate case only allows them a certain budget for asset maintenance replacement. Their need is 6x of that budget. So how do they deal with it? How do they solve that problem? Understand what assets are risk, understand the pattern of behavior and failures under different load conditions, be able to address that dynamically in real time, as well as have that intelligence feed back into their asset planning and asset investment planning. I'm going to share with you another use case, which is a smart meter use case, and it's always better when I don't talk. Let some professional talk. So could you roll that, please? Oh.
We start with a high-level view of several districts, with the colors showing us the percentage of smart meters that have been read in each one. We seem to have a problem in the district shown in red. Our assessment is supported by the data displayed in the bar chart shown at the bottom of the screen. We also see a high number of unread meters on the 27th day of the billing cycle. Let's drill into the district to determine why. Using space-time insight, we can filter the data using information layers. If we turn on the meter details layer, the display shows smart meters that haven't been read for over 5 days. We can use a natural language query to dynamically refine that duration, in this case to 15 days. By sorting the resulting list of unread meters, we see a high correlation with the 27th day of the billing cycle. Now, let's find out where those meters are located. Space-time Insight dynamically synchronizes tabular and geospatial displays, so by clicking on a meter record in our list, we see the physical location of the meter. If we now navigate to that area on the map, it becomes clear that the whole neighborhood is affected, and by addressing the issue for that area, we can positively impact revenue in this billing cycle. Now that we know where the problem is and when it happened, the next step is to determine why it's occurring and how to resolve it. We can overlay any data sources on the display to examine correlations between them. In this case, let's look at whether our communications infrastructure is impacting the smart meters in that neighborhood. The red icons on the geospatial display and the summary table show us that some access points and relays are not responding correctly, and that those access points are linked to the unread meters. Having found the cause of the problem, we can now dispatch the appropriate field service personnel to address it. As we've seen, Space-Time Insight brings situational intelligence to life, enabling you to intuitively visualize and analyze complex data and make fast, informed decisions as a result.
By the way, what you want to see is a lot of this actually happen automatically, right, and being processed in the background, and we need to allow the operators to be alerted to a condition or problem or out of normal operating condition, but then also give them the tools to be able to do what we just showed here in a very rudimentary smart meter use case, but high impact, rudimentary but very high impact, right? Avoiding missed billing cycles actually could add up to quite a bit of money. So these applications that we've created in these 4 areas, 4 categories of smart meter, asset intelligence, grid intelligence, and renewable intelligence have a set of common characteristics. And these common characteristics, or the anatomy of these applications, are, first of all, around the data interfaces. So I think my colleague before had the list of 5 questions you need to ask. Those are absolutely spot on. What data do I need? What problem am I trying to solve? What data do I need? Where is the data source? Where's the data coming from? And what we've developed are pretty much out-of-the-box adapters for the most common data sources from the business systems, the operation systems, and events, weather, et cetera. So being able to bring that data in, also being able to bring in domain-specific models and knowledge in addition to what we built out. So the next piece of it is really the domain-specific knowledge on behavioral patterns. What are the behaviors that we're generally looking for? Ultimately, what objectives do they meet? What constraints do they meet? What KPIs are we tracking and measuring in doing so? And, of course, how do we then visualize that and present all of that data, information, and analysis, the result of the analysis, to an operator in a digestible form or in an actionable form? So these are the common components of the anatomy of our applications and solutions. We clearly range between 8 to 10 weeks of implementation and just basically out of the box bring this to the table, having something operational running, again, depending on the data sources and availability of data and the modeling and all of that, right? 2, 6 to 9 months. So there's big variance in the implementation timeframes. But the idea is to, over time, to package as much of that domain knowledge, expertise, the analytic models, the visualization models, the data adapters, and deliver that to the customer so we can continue to accelerate the rapid deployment. And I think one of my colleagues earlier said, and I think it was our Microsoft colleague that said, the biggest challenge and issue is waiting to get the results from IT, right? So we need to continually accelerate that. And it's really important because we need to continually evolve. As we begin to see conditions, we need to have the ability to go in there and dynamically alter what we're seeing in the system and how the system behaves so that we can dynamically and continually evolve these use cases. So the benefit of situational intelligent applications. Faster time to value. We talked a little bit about that, and I could talk to you a lot more about that during breaks, et cetera. I'd be more than happy to do that. Reduced resource requirement. The time to implementation, the amount of deep resources, we all know resources are a big constraint. How many people does it really take to do this? This is really a key consideration. This is what situational intelligence does. Not only, we talked about the resources going to half, so we're constantly looking at that reduction of resources, but also the loss of that expertise over time, being able to capture that and maintain that organizational, institutional knowledge and continue to evolve and add to it. Lower dependence on IT in a good way. It's not really, eliminating IT. Actually, it allows IT to become much more relevant to the business in terms of the applications and solutions and the value that the business is going to get out of that data and the time to value for that data. And, of course, the higher quality and the standardization of the user interface, I think all my colleagues talked about it, a single view, dashboards that everybody in the organization can use, and make it intuitive as possible, right? I would also add to this that it's just not about the higher quality and standardization of the user interface, but it's also about the standardization of the operating procedures. The greater the consistency in the action taking and the standardization of the operating procedures, the better our adherence to safety, regulatory, and other requirements, right? Business operation requirements, the less the business and operational risk that we deal with. So, as I mentioned earlier, we have developed a situational intelligence suite over the past several years that we've been working with some of the major IOUs and ISOs globally. And these have culminated, the anatomy of the application sort of culminated into a set of applications and application solution areas around smart meter intelligence, asset intelligence, grid intelligence, and renewable intelligence. And of course, we also have a highly intuitive, very easy to use development environment that allows our customers and partners to continually evolve these applications and solutions in real time. So continue to be able to add to it, evolve it, and enhance it, and customize it, adapt it to the needs of the business, the changing needs of the business. And that's really key. And of course, our core platform that provides all of the key capabilities, which is around visualization. I always have to go back and say, please don't think of us as just a visualization engine. Visualization is a commodity, right? Putting maps on putting dots on a map is a commodity. What's really important is not just the correlation, but also the analytics that are behind that visualization, the pre-processing, the analytics. It's not just about layering the data in there and putting the data layers in there, mapping it. It's about correlating, analyzing, and then representing the integration of those data layers into what the operator or the person working with the application sees. And of course, it's about real-time analytics moving towards predictive analytics. So that's really the goal. The goalpost is now predictive analytics and working towards that. So in summary, situational intelligence, we talked about it. It is an evolution of situational awareness, and it's not just about operational intelligence. It is about a combination of operational intelligence and business intelligence, and it's about giving our folks a way to visualize all of that in a very intuitive way and take action on it, analyze and take action on it. It is about looking at the performance of all assets, not just individually, but in combination, right? Transformers are connected to transmission lines, are connected to points of distribution. It's about understanding that whole thing. It's renewables are feeding that. It's about understanding that. It's about understanding dynamic and changes in load in real time and the effect and impact on that infrastructure. It's about understanding where the risks are occurring, but it's also about understanding where the normal operating conditions are. It's a good thing to know, right? That piece is working really well. That piece is a bottleneck. We need to address it. It's about visual analytics for big data, not just big data in terms of size and volume, but also complexity and the real-time nature of the data. It is about looking and being able to act on critical situations in real time and, more importantly, over time in a predictive fashion. So with that, thank you. And any questions?